Chapter 2. Thinking with Method. Most of us, at those rare intervals when we think at all, do so in a slipshod sort of way. If we come across a mental difficulty, we try to get rid of it in almost any kind of hit or miss manner. Even those few of us who think occasionally for the mere sake of thinking, generally do so without regard for method, indeed are often unconscious that method could be applied to our thought. But what is meant by method? I may best explain by an example. From somewhere or other, a man gets hold of the idea that the proper subjects are not being taught in our schools and colleges. He asks himself what the proper subjects would be. He considers how useless his knowledge of Greek and Latin has been. He decides that these two subjects should be eliminated. Then he thinks how he would have been helped in business by a knowledge of bookkeeping, and he concludes that this subject deserves a place in the curriculum. He has recently received a letter from a college friend containing some errors in spelling. He is convinced that this branch of knowledge is being left in undeserved neglect. Or he is impressed by the spread of unsound theories of money among the poorer classes, and he believes that everybody should receive a thorough course in economics and finance. And so he rambles on, now on this subject, now on that. Compare this haphazard, aimless thinking with that of the man of method. This man is confronted with the same general situation as our first thinker, but he makes his problem a different one. He first asks himself what end he has in view. He discovers that he is primarily trying to find out not so much what subjects should be taught in the schools, as what knowledge is of most worth. He puts the problem definitely before himself in this latter form. He then sees that the problem, what knowledge is of most worth, implies that what is desired is not to find what subjects are of worth and what are not, but what is the relative value of subjects. His next step, obviously, is to discover a standard by which the relative value of subjects can be determined. And this, let us say, he finds in the help a knowledge of these subjects gives to complete living. Having decided this, he next classifies in the order of their importance the activities which constitute human life, and follows this by classifying subjects as they prepare for these activities. Point 1. Needless to say, the results obtained by this thinker will be infinitely more satisfactory than those arrived at by his unsystematic brother. Method, then, is essential. But how are we to apply it in all cases? Now there are methods without number, and in many cases a problem will require a method all its own. But we here purpose to take up only those most general in application. Before considering these methods of thinking, however, it would be well to ask ourselves what thinking is. As stated before, the term is loosely used to cover a wide range of mental processes. These processes we may roughly divide into memory, imagination, and reasoning. It is the last only with which we have to deal. I admit that development of the memory is desirable. I admit that development of the imagination is equally desirable. But they are not the subject of this book. By thinking, I mean reasoning, and our present purpose is to find the nature of this process. Modern psychologists tell us that all reasoning begins in perplexity, hesitation, doubt. The process of reasoning is one of problem solving. The occasion for the reasoning is always a thwarted purpose. 2. It is essential we keep this in mind. It differs from the popular conception even more than may appear at first sight. If a man were to know everything he could not think, nothing would ever puzzle him. His purposes would never be thwarted. He would never experience perplexity or doubt. He would have no problems. If we are to conceive of God as an all-knower, we cannot conceive of him as a thinking being. Thinking is reserved for beings of finite intelligence. Were we to study the origin and evolution of thinking, we would doubtless find that thinking arose in just this way, from thwarted purposes. If our lives and the lives of our animal ancestors had always run smoothly, if our every desire were immediately satisfied, if we never met an obstacle in anything we tried to do, thinking would never have appeared on this planet. But adversity forced us to it. Tickle a frog's left leg, and his right leg will immediately fly up and scratch it. The action is merely what psychologists would call a reflex. Absolutely no thinking takes place. The frog would do the same thing if you removed its brain. And if you tickle its right leg, its left leg would fly up to scratch. But if you tickled both legs at once, they could not both fly up and scratch each other. It would be a physical impossibility. Here, then, is a difficulty. The frog hesitates. Thinking steps upon the scene. After mature deliberation, the frog solves his problem. He holds his left leg still while he scratches it with his right. Then he holds his right leg still and scratches that with his left. We cannot, then, think on general principles. To try this is like attempting to chew laughing gas. To think at all requires a purpose, no matter how vague. The best thinking, however, requires a definite purpose, and the more definite this purpose, the more definite will be our thinking. Therefore, in taking up any special line of thought, we must first find just what our end or purpose is, and thus get clearly in mind what our problems are. Advising a man to ask himself what his problems are may seem absurd. But it is just this confusion as to what they want to know which has driven men into error time and time again. The history of the never-ending philosophical controversy between materialism and idealism is largely a history of different ways of stating the issue. The progress made is mainly due to the increasing definiteness with which it has been stated. One of the most frequent sources of confusion in stating questions is in failure to distinguish between what is and what ought to be. Considering woman's suffrage, a man will ask himself, what is woman's sphere? When he really wants to know not what woman's sphere actually is, but what it ought to be. Our first step, then, is to get our problem or problems clearly in mind and to state them as definitely as possible. A problem properly stated is a problem partly solved. What we will do next depends on the nature of the question. In the example, what knowledge is of most worth? We proceeded to look for a criterion of worthiness. And this was really a restating of the question. For instead of asking ourselves, what knowledge is of most worth? We began asking what knowledge best prepares for complete living. Our next move was to classify. This is essential not only to systematic reasoning but to thinking of any kind. Classification is the process of grouping objects according to common qualities. But as almost all objects differ in some qualities and almost all have some qualities in common, it follows that, contrary to common belief, there is no one classification absolutely essential to any group of objects. An infinite number of classifications may be made, because every object has an infinite number of attributes, depending on the aspect we take of it. nor is any one aspect of a thing truer than any other. The aspect we take depends entirely on the purpose we have in mind or the problem we wish to solve. As William James pointed out, now that I am writing, it is essential that I conceive my paper as a surface for inscription. If I failed to do that, I should have to stop my work. But if I wished to light a fire and no other materials were by, the essential way of conceiving the paper would be as combustible material, and I need then have no thought of any of its other destinations. It is really all that it is, a combustible, a writing surface, a thin thing, a hydrocarbonaceous thing, a thing 8 inches one way and 10 another, a thing just 1 furlong east of a certain stone in my neighbor's field, an American thing, etc., ad infinitum. 3. And if the reader insists that these qualities are merely accidental, and that what the thing really is just paper and nothing else, the reply is that the reader is intellectually petrified, that though paper may be our commonest title for it and may suggest our usual purpose with it, yet that purpose and this title and the properties which this title suggests have in reality nothing sacramental about them. So because you have classified something from one aspect, do not imagine that you are necessarily precluded from classifying it from any other. A man who is studying the theory of money may divide the medium of exchange into standard money and credit currency. But this need not keep him from viewing it as coins, government notes, and bank currency, nor should it prevent him from classifying it into, say, 1 hand-to-hand money, 2 written or printed orders of one party to pay specified sums to another, and 3 book accounts. Point 4. All these classifications will be true. All may be useful for a full comprehension. Every classification should of course be logical, but it is far more essential that it be utilizable. And while we are treating of utility, we might note that this pragmatic method can be applied with profit to nearly all our positive problems. Before starting to solve a question, while deciding, for instance, on the validity of some nice distinction in logic, we should ask ourselves, what practical difference will it make if I hold one opinion or the other? How will my belief influence my action? Using the word action in its broadest sense. This may often lead our line of inquiry into more fruitful channels, keep us from making fine but needless distinctions, help us to word our question more relevantly, and lead us to make distinctions where we really need them. We are now ready to consider in order a number of constructive methods in thinking. One method applicable to almost all problems is what we may call either the deductive or the a priori method. This method reaches a conclusion without observation or experiment. It consists in reasoning from previous experience or from established principles to particular facts. It may, however, be used to confirm observation and experiment as well as to take their place. Take the all-important questions in biology of whether or not specific characteristics acquired by an animal during its lifetime are inherited by offspring. The a priori method would examine the structures of the body, the germ plasm from which the offspring develops, and the relation between them, and would ask just how a specific change in the body could affect the germ. If it were found that the tissues that are to continue the race were set off so completely from the structures of the body as to make inconceivable any manner by which they could be influenced by changes in these structures, then this method would decide that acquired characteristics are not transmitted. Let us take another example. Both the supporters and opponents of woman suffrage have often decided the question without consulting at all the actual results achieved in the states where women vote. They have settled the question to their own satisfaction merely on a priori grounds. They have considered woman's supposed mental qualities as compared with man's, and have decided on her fitness for the ballot solely from these considerations. It must be remembered, however, that before women were admitted to suffrage anywhere, deductive or a priori reasoning was the only kind possible. It is often helpful to look at a problem from the viewpoint of different sciences. A problem in political science will very likely have an economic aspect, whether it concerns taxation, tariff, trusts, or the ownership of land, and so we may look at the question solely from the viewpoint of economics. But the problem may also have an ethical aspect. If it is proposed to pass a universal prohibition law, you may ask, has the government the right to interfere in this way with personal liberty? Again, we could take a psychological view. We would decide from our knowledge of human nature just what the effect of an alcohol prohibition law would be, whether it would not drive men to even more dangerous drugs such as morphine and opium. And now we come to a whole host of effective methods, all of which may be classed as comparative. The comparative method is as old as thought itself, but it is strange that even scientists did not begin to use it consciously and consistently until almost the present generation. Nowhere is it better illustrated than in modern psychology. Most of the so-called branches of psychology are merely different forms of the comparative method of treatment. Abnormal psychology is merely a comparison of abnormal mental types with normal mental types for the light they throw on each other. Child study is a comparison of the mind of the child with that of the adult. Animal psychology is a comparison of the actions of animals with each other and with those of man. And none of these methods is of any value except insofar as it makes use of comparison. Often consciously used in the consideration of problems is the so-called historical method. This method, as its name implies, consists in obtaining knowledge of a thing by considering its past record. The word history is popularly used in so narrow a sense, however, being restricted only to the history of nations, and often merely to the political history of nations, that we can avoid confusion by calling this method the evolutionary. In the final analysis, the method is comparative, for it really consists in comparing a thing at one period of development with itself at another period. Let us take our example from political science. The historical method, in its popular sense, has been so much used here, even to the exclusion of other methods, that it would seem needless to speak of it. But often the method has been abused, and often it has not been given broad enough treatment. It traces the growth of an institution, or of an idea, personal liberty, say, through successive periods. It notes what the path has been and judges of the probable future tendency. But a far broader outlook than we get from this narrowly conceived historical method is furnished by evolutionary sociology. Here we inquire into the origin of society and of the various trades, industries, professions, and pursuits of all kinds, and to do this we go far into prehistoric times. Nowhere is the evolutionary method more strikingly seen than in biology. Since Darwin's great theory was promulgated, the science has gone forward by leaps and bounds. We have derived untold benefit from a comparison of man and animals in the light of this hypothesis. Even study of the development of individual man has been aided. The discovery of the fact of evolution constituted an incalculable advance. But the method for study which it furnished was of even greater importance. I have spoken of the comparison of man and animals in the light of this evolutionary hypothesis. This brings us to a point which must be kept in mind in practically all observation. We are often exhorted to observe. Presumably, we are to do this on general principles. Such advice is about as foolish as asking us to think on general principles. Imagine for the moment what would happen if you started right now to observe as much as you could. You might begin with this book and notice the size of the type, the amount of margin, the quality of the paper, the dimensions of the page, the number of pages. But you have by no means exhausted the number of properties possessed by this book. You must observe that it is also combustible, that it is destructible, that it is machine-made, that it is American printed, that it is such and such a price, that it weighs so many ounces, that it is flat, that it is rectangular, that its thickness is so much. The absurdity is obvious. If we started out merely to observe with no definite purpose in mind, we could keep it up forever and get nowhere. 9 out of every 10 observations would never be put to use. We would be sinfully wasting our time. To observe most profitably, just as to think most profitably, we must have a definite purpose. This purpose must be to test the truth of a supposition. A concrete example will make this clear. A man has been shipwrecked on an island and believes himself to be alone there. One day, as he is walking along the beach, he discovers footprints. How did they get there? His first assumption is that they are his own. It occurs to him, however, that he had not been near this spot for over a week, and that yesterday's storm would have washed any footprints away. This objection is confirmed by making a footprint himself and comparing it with the one observed, and noticing that they differ markedly. The footprints being those of someone else, how did the man who made them get there? The first supposition is that he came in a boat. The idea of a small boat is dismissed because of the assumed great distance of this island from other land. Therefore, the man must have come in a large vessel. But the footprints lead to a wet part of the sand and the tide is just going down. In this case, they are very recent, made not more than a half hour ago. This being so, the man who made them could not have had time to get back to any ship and sail out of sight. If he came in a ship, it should be still in view. The discoverer of the footprints climbs a tree from which he can view the sea around the entire island. He can sight no vessel. The supposition or hypothesis that the unknown came in a ship is abandoned. Then the suggestion comes that the unknown has been on the island during the entire time that the shipwrecked man thought himself alone. This suggestion is tested in a manner similar to the others. The example sums up roughly the general process of all thought and brings out the motive and value of observation. Let us analyze it. The first thing to happen is the arousal of a feeling of perplexity, the appearance of a problem. The man has been shambling along, doubtless thinking in that loose sense referred to. He has perhaps kicked several stones loose that would have set a geologist worrying, and has picked branches from bushes which would have puzzled a botanist. But this man has not had his curiosity aroused until he has come to these footprints. His thinking starts with his perplexity. After this doubt has been aroused, the most obvious solution suggests itself: my own footprints. But if true, this suggestion involves the coexistence of other facts, some of which are known and some of which may be determined. Thus, if they were his own footprints, it must, among other things, necessarily follow 1. That he had been at that spot before, 2. That nothing had happened since that time to remove the prints, 3. That the footprints corresponded to his own. The first consequence involved, that he had been there before, was a fact, but the others were not, and so the suggestion was dropped. Then a second hypothesis occurred. The man came in a ship, and this was tried out in a similar way. Notice that in each case the consequences dependent on the truth of the suggestion are tried out, 1 by memory, 2 by observation or experiment. Memory came when he thought of the last time he had walked near the beach and of yesterday's storm. Observation came when he compared his footprint with the one seen, when he followed the footprints along the sand and noticed where they led, when he climbed a tree and looked for a ship. There were a number of other things which he could have observed. He might have noticed the texture of the sand, what kind of a tree he was climbing, what sort of clouds were in the sky. But he did not observe these interesting things simply because they would throw no light on the truth or falsity of his supposition. In another problem, one of these facts might have been of value. It is almost possible to sum up the whole process of thinking as the occurrence of suggestions for the solution of difficulties and the testing out of those suggestions. The suggestions or suppositions are tested by observation, memory, experiment. Supposition and observation alternate. The first facts observed, in the case foregoing the footprints, make the problem, they suggest the supposition. A supposition is that the man came in a boat. If the man came in a boat, such and such would be the case. The boat would still be visible, etc. If the boat is not visible, the supposition is given up and another one made. If the boat is visible, the supposition is confirmed. This is a case of simple and rudimentary thinking, but it illustrates roughly the process of thought on even the most complicated problems of science. The methods we have been discussing may all be considered simply as means for helping good suggestions occur to us. Let us illustrate by considering a few methods of rather restricted application. We are often aided in the solution of a problem by asking its opposite. If we ask ourselves what constitutes gracefulness, we may find ourselves at a loss for suggestions because gracefulness always seems so natural. But if we ask its opposite, what constitutes awkwardness, suggestions are more apt to occur. If we find, for instance, that awkwardness consists in undue bodily effort in making a movement, we may assume that gracefulness consists in ease of movement. In the same way, the question of what makes us forget may be helped by asking ourselves what makes us remember. And light may be thrown on the causes of success in business and in life by a study of the causes of failure. The method of analogy likewise encourages suggestions. Analogy consists in noting certain likenesses between things and assuming that they also possess other common qualities. Striking use of analogy is made in dealing with the planet Mars. At each pole there are great white patches. The size of these varies markedly with the seasons, which suggests that, like the Earth, Mars has great areas of ice and snow at its two poles which melt and reform. The general surface is reddish, but 3/8 of it is covered by blue-green tracks, and these are usually inferred to be seas. These again are connected by an intricate system of blue-green lines, which some scientists believe to be canals, but on this there is much controversy. In Mars we have at once an illustration of the possibilities and dangers of analogy. In the whole discussion of constructive method thus far, I have left out the two most common and useful methods of all. The first of these we may designate by a somewhat formidable title: empirical observation. Empirical, at least for our present purposes, means merely that which comes within experience. But the term is generally opposed to scientific. Thus Dewey gives an example. A says, "It will probably rain tomorrow." B asks, "Why do you think so?" And A replies, "Because the sky was lowering at sunset." When B asks, "What has that to do with it?" A responds, "I do not know, but it generally does rain after such a sunset." He does not perceive any connection between the appearance of the sky and the coming rain. He is not aware of any continuity in the facts themselves, any law or principle, as we usually say. He simply, from frequently recurring conjunction of the events, has associated them so that when he sees one he thinks of the other. 5. This, however, is not what I mean to imply by the term empirical observation. I mean rather thinking on the basis merely of facts which occur in the natural course of events, which have not been systematically produced by ourselves or others for the purpose of solving a problem. Logicians usually call this method simply observation and oppose it to experiment. But I object to calling this simply observation because experiment itself is really observation. Only in one case we observe merely events which happen to occur, and in the other we observe the results of events which we have made occur. The true way of distinguishing these two methods would be to call one empirical observation and the other experimental observation. This empirical method, if indeed I am justified in calling it a method, is the most common in all thinking. To give examples of it would be to show how men generally think. But the method has real value, and may even be the most important of all, for if we thought without it our ideas would doubtless be original but very dangerous. Let us apply it to some of the problems considered under other methods. Empirical observation is used where experiment is impossible, often, unfortunately, where experiment is merely inconvenient. In political science, the empirical method would consist in noting the effect of certain laws, e.g., tariffs of different countries and of the same country at different periods, and noting economic conditions at the time the different tariffs were in effect. Allowance would be made for other factors which could influence the country's economic condition, and the effect of the tariff could then be determined. The empirical method of dealing with meteorology, the science of weather, would consist in making a study of cloud formations, wind velocity, moisture in the air, temperature, etc., and noting what conditions usually or perhaps invariably followed certain of these conditions. From this, conclusions could be drawn as to what weather to expect following certain conditions. But valuable as empirical observation is, and often as we must use it, it should never be employed when we can experiment. When the empirical method is rightly used, allowance always has to be made for certain irrelevant factors. But making allowances is always sheer guesswork. The experimental method consists not in making allowances for certain factors, but in eliminating those factors. In our example from political science, experiment is practically impossible, because the factors which may influence economic conditions are innumerable, and even were they few, no country could survive the dangers of being experimented upon, to say nothing of its permitting it. Experiment is similarly impossible in dealing with weather conditions directly. It is impossible in astronomy. I say probably because there are still many irrelevant factors which might influence the result. For instance, if you had a different teacher for each group, one group might make greater progress not because of the method but because of the teacher. This means either that one teacher should teach both groups, or that we should multiply the number of groups and the number of teachers, and have half the teachers teaching half the groups by one method, and the other half teaching by the other method. Of course, here too, the more we could multiply the number, the better it would be. Even then, there might be some reasonable question as to the validity of the experiment, for it might be that one method would tend to encourage faster progress at the beginning, but that the other would lead to greater progress in the long run. This could be determined only by carrying our experiment over a long period. And we might still have irrelevant factors, for the machines on which one group learnt to typewrite might be superior to those on which the other group learnt, and this factor would have to be eliminated in a similar way to the others. The experimental method has been well summed up by Thomson and Tate in their Natural Philosophy. In all cases when a particular agent or cause is to be studied, experiments should be arranged in such a way as to lead if possible to results depending on it alone. Or, if this cannot be done, they should be arranged so as to increase the effects due to the cause to be studied, till these so far exceed the unavoidable concomitants, that the latter may be considered as only disturbing, not essentially modifying the effects of the principal agent. In all experiments, one must exercise ingenuity in finding other causes besides the one to be studied which may possibly influence a result, and in eliminating these. It might benefit the reader considerably if he were to think out for himself how he would apply experiment in its most thoroughgoing form to solve a given question, say the inheritance of acquired characteristics. I have now cited enough methods to at least indicate what thinking with method means. To satisfy a certain human craving, all of these have been named, though sometimes arbitrarily. Of course, each may have to be modified to some extent to adjust it to different problems. I must repeat, there are methods numberless, and some problems will require methods all their own. But what is important is that every problem should be dealt with by as many methods as possible. Doubtless you have used, at some time or other in the course of your thinking, nearly every one of the methods I have so far suggested. But the point is not that you have never used these methods at all, but that you have not used them often enough. You were unaware what method you were using. Consequently, you used it only occasionally. You used it only when you stumbled on it accidentally. To formulate methods is to bring them to your attention, so that you may use them always, thoroughly, correctly, consistently. We have treated political science from most angles. We have applied more than one method to several other problems. To still further clarify, exemplify, and impress this point, I shall show the application of method to one more subject. Suppose you wanted to invent a system of shorthand and wanted to make it as perfect as possible. How would you go about it? Your first step should be to restate your question most advantageously. You want to create certain characters or symbols which will 1. Take the shortest time to write, 2. Will be easily recognized by yourself or others, even if written carelessly, and 3. Which will not be so numerous or so complex as to be difficult to learn. You may decide that such symbols would have even further requirements. Next, you should decide on the methods to use in attacking your problem, this in order not to forget any. Now assume you have decided on these methods and that the first is the a priori. Your conclusion might be that it would be impossible to have a different symbol for every word, and that it is necessary to have some sort of alphabet. Should this alphabet be based on that used in longhand? That is, should merely a simpler symbol stand in place of each letter? Or should a different symbol represent each sound? Or would it be possible to have a different elementary symbol for each syllable? Having decided the basis for your symbols or characters, you will know at least approximately the number required. Your problem will then become that of making the characters as simple as possible, so that they may be written most quickly, and yet as different from each other as possible so that if written carelessly, as they will be when written swiftly, they may be easily recognized. You might try writing down all the simplest symbols you can think of. Or you might ask yourself whether there is any fundamental geometrical figure from which you can derive your symbols. Or you might study the simplest and easiest movements of the hand and base your characters on these. This a priori method is most apt of all to provoke real thinking. It should therefore be taken up before any of the others. Not only is it best for making you think deeply, but it will be more likely than any of the others to make you think originally. However, whether attended by great or little success, this method should be followed by others. Not the least fruitful of these would be the evolutionary. This, of course, would consist in studying the history of shorthand, finding out the direction in which it has been tending, and thus anticipating in some degree its future development. As this method is comparative, we would naturally be led from it to comparing the shorthand systems of today and assaying the good and bad qualities of each. These could only be assayed if we knew something of shorthand theory, and thus our experience with the deductive or a priori method would be of service. Implied in here is a method of different nature than any we have yet discussed, but one of immense help. In turning from the deductive method to a study of shorthand systems which others have developed, you have an opportunity to compare the results of your own thinking with those obtained by others. If you have failed to solve the question in as good a manner as these others, you can ask yourself wherein and why your own reflections and ingenuity fell short. If you follow this method with all problems, i.e., thinking a thing out for yourself before looking up what others have thought, you will soon improve your thinking surprisingly. The method is capable of application in every problem, from inventing an adding machine to trying to find how the plumber got that $3.46 on the bill. But to return to shorthand, we still have the empirical and experimental methods. In this particular case, the difference between them would be simply one of degree. We could find, for instance, what systems were used by the fastest shorthand writers. But we could get nothing conclusive from this, for we would have to make allowance for the natural ability and length of training of these writers. From merely looking at two outlines or characters, it is often difficult to tell which can be written faster. This could only be tested by writing hundreds in a row and finding the time it took to write the same number of each. Of course, such experiment is capable of indefinite expansion. In dealing with method heretofore, I have at times come dangerously near to making a false assumption. I have been talking as if a man who took up political science, shorthand, or any other subject were dealing with only one problem. As a matter of fact, he is dealing with a whole series of problems. Just how many it is difficult to say, because no problem worthy of the name is an indivisible unit, and may always be broken into smaller problems. The whole science of aesthetics is included in the simple question, what is beauty? The science of ethics is merely the answer to what is right conduct, and metaphysics may be reduced to the problem, what is reality? But when we come to deal with any of these, we instinctively break them up into smaller and more concrete problems, making the treatment easier, just as a general attempts to split his enemy's forces, so that he can annihilate one section at a time. Often, indeed, the very division of the larger problem into smaller problems constitutes its solution, for we finally come to a problem which practically answers itself, and which we recognize as being included in or a particular form of some more general problem to which we already know the answer. A man sets before himself the question, what is the proper sphere of government? Perhaps he will first of all consider certain different specific activities which might possibly be supposed to come within the sphere of governmental interference. He might ask himself, for instance, should the government interfere with freedom of contract? Notice that he has here temporarily made his problem narrower. He has chosen to break it up in order to deal with it part by part. But even when he came to cope with this smaller problem, he would probably find it necessary to break this up, and he would therefore take a specific example. Suppose a man works for so much an hour, and that 9 hours work a day gives him the minimum amount on which he can live and support his family. Would it be wise to limit the legal working day of such a man to 8 hours? This problem practically answers itself, and so further division is unnecessary. Of course, the answer to this does not determine the answer to the original question, for other parts still remain to be considered. In fact, much of the success of our thinking will depend upon just how we divide our big problems into subsidiary problems, and just what our subsidiary or subordinate problems are. This will depend to some extent on our own natural sagacity, and to some extent on mere chance. No rigid rules can be laid down. The only advice which can be offered is that when a thinker breaks up a problem, he should do so with an eye to utility and definiteness. John Stuart Mill, in an essay on Jeremy Bentham, pointed out that the secret of the latter's strength and originality of thought lay in his method, which may be shortly described as the method of detail, of treating wholes by separating them into their parts, abstractions by resolving them into things, classes and generalities by distinguishing them into the individuals of which they are made up, and breaking every question into pieces before attempting to solve it. The method was not absolutely original with Bentham, but whatever originality there was in the method, in the subjects he applied it to, and in the rigidity with which he adhered to it, there was the greatest. The systematic thinker is careful of the manner in which he marshals his difficulties. He knows that certain problems should properly be considered before certain others, and he saves himself labor and sometimes error by considering them in that order. Before asking himself how government should cure a given social evil, he first asks whether it is the duty or even the right of the state to attend to that particular evil at all. In other words, before asking what the state should do in any particular case, he considers first what the proper sphere of government is. It must be admitted that a previous question often cannot be discovered until one has actually attempted the solution of a problem. In the foregoing instance, it would be difficult to determine the proper sphere of government by any other method than a consideration of particular cases where government interference suggests itself. In fact, it is only by deep reflection on a subject that we come to realize most of the problems involved. You walk along the road with your friend the botanist, and he stops to pick what looks to you to be a common wildflower. He muses. I wonder how that got in this part of the country? Now that is no problem to you, simply because you do not happen to know why that particular flower should not be there, and what men do not know about they take for granted. Knowledge furnishes problems, and the discovery of problems itself constitutes an intellectual advance. Whenever you are thrashing out a subject, write down every problem, difficulty, and objection that occurs to you. When you get what you consider a satisfactory solution, see whether or not it answers all of them. I have stated that method is essential to good thinking. I have given rules and examples of methodic thinking, but I do not want to create a false impression. If a man has not within him the materials of a thinker, no amount of method can make him one. Half the thinking process, as pointed out, depends on the occurrence of suggestions. The occurrence of suggestions depends on how ideas are associated in a man's mind. While this depends to some extent on the education and the whole past life and environment of the individual, it depends far more on inborn mental qualities. All method can do is to awaken the most fruitful associations of ideas already in mind. Hence, the more methods we adopt, the greater the number of views we take of any problem, the more solutions will suggest themselves. There is one further reason why we should take as many different viewpoints as possible. In our example of the inheritance of acquired characteristics in animals, if we had been sure that the results of our deductive reasoning were correct, it would have been a sinful waste of time to experiment. But when we attack a problem by several methods, we can compare the results from each. If these results agree, we have good evidence that our solution is correct. But if we have adopted quite a number of viewpoints, and have not let the results of one influence those of the next, they are almost certain to be at variance. This means that we have erred in applying one or several methods. How are we to find which of the methods it was, and how are we to prevent such errors? This is the subject of our next chapter, but it could be applied quite easily to most questions. Suppose you wanted to determine beyond question which of two methods of teaching a given subject was the better. We shall assume for the moment that you have unlimited time and money to experiment. It may be thought that we could settle this simply by teaching one person according to one method and another person according to the other, and that we could determine the relative merits of each method from the progress made by each pupil. This, however, would be practically of no use whatever. One pupil might be naturally brighter than the other, and so would naturally learn quicker, even were he taught by an inferior method. To make the experiment of any use, we should first take two groups of pupils, the larger the better. For it is obvious that if we take a great number of pupils and place them in two groups, the differences between the individuals will tend to offset one another. Let us say the subject is one in which the progress can be quantitatively measured, say typewriting, and let us suppose there are 50 pupils in each group. If after a given time all the pupils in one group had attained a greater speed with accuracy than all the pupils in the other, the test would be almost unquestionable. This would be even more conclusive if the groups were reasonably well balanced. For if all of one group were men and all of the other were boys, the men might make more rapid progress than the boys even with a less efficient system. But it should be easy to divide classes and groups so as to have a reasonable balance of intelligence between them. The probable result of any experiment would be that in neither class would all the pupils make more progress than all the pupils of the other. though you might find that the preponderating majority in one class improved faster than those in the other, and this would probably be sufficient to indicate the superiority of one method, even though one or two pupils in the second group progressed faster than one or two in the first.